Hello, we are going to look at how to get angles for vectors from component vectors, specifically in respect to the positive x-axis. So what do I mean by that? I'm looking at your standard coordinate plane here, where I've highlighted in red the positive x-axis. X-axis here, of course, is the horizontal axis that's running through the graph. And then the positive x-axis is just where every spot where you've got x is greater than 0. And we're using this, we used it a lot in things like the unit circle. It's pretty common, and it's a way that we can speak about these vectors easily, because you can talk about them with respect to different angles. If we wanted to, we could say with respect to the y, but then we've got a lot of stuff going on. And we can, but just for starters here, let's go ahead and focus just on this positive x-axis. So you may find yourself looking for something like this: v equals -3, -4. That is a vector, and you may want to find the angle, again with respect to the x-axis. So here's the first step that you're going to want to do. You're going to want to sketch it out. Now, before I fully sketch it out, I'm going to do a kind of a mini sketch here. Okay, that side is 4, that side is 3. Take a note of the orientation here. The -3 I actually went to the left, and the -4 I went down. What you can get using good old trigonometry is, if this is a right angle, so you can get this angle right here, which is nice, but what we really want to get is, if I have a vector, let's say that goes, it's going to be going down here, I want this angle. And this angle, does it look like it is greater than or less than 180 degrees? Okay, how about this angle right here? Does this appear to be greater than or less than 180 degrees? This angle is clearly of a smaller measure than this one, but the two are connected together. Let's take a look at how we can solve this. So sketching is the first step that you should do. Once you have sketched this out, then you can kind of see where you expect the angle to be. At this point, I've got a triangle here with sides of 3 and 4. So, and I want to focus on the angle that is at the origin, this angle right there. So that would make the 4 my opposite, the 3 my adjacent. I'm also going to disregard the negatives here, really. I'm going to take the absolute value because you cannot have a negative distance or negative length. The negatives just give you the direction. So I'm going to be using the absolute value for these. So I have the opposite and the adjacent. Going back to SOHCAHTOA, I know that with opposite and adjacent, I've got tangent. So the tangent of this angle is going to be my opposite, which we said was 4, over the adjacent 3, which means that theta is just going to be my inverse tangent of 4 over 3. And using your calculator, you can determine that to be, we'll go to the nearest degree here. It's about 53 degrees. So again, that means that this angle right here is 53 degrees. But I want everything from the positive x-axis. So you can just add in this case, everything else that you need. In quadrant 1, that's 90 degrees. In quadrant 2 over here, you have another 90 degrees. And then you have this extra 53 degrees down here that takes you to the vector. So my final measure for vector v is going to be 90 plus 90 plus 53, which gives you 233 degrees. This will work in this case. I want to show you one other one before we get to the summary here, just to be very clear. So suppose I've got a case like this. Suppose I do all this. I have my vector, it goes down here, and let's just say, oh, for simplicity's sake, that this is, let's say this is 50 degrees right here. This is what you find using trig, because you're using this side over here, you're using this side there, there's your triangle. But this time, notice I'm not going to add 50 degrees because, again, we want to go all the way around. So here is 90, here is 90, here's another 90. Here you can think of it in two different ways. You can either think of adding 90 to get all the way back up to your x-axis. That's 360 degrees. 4 90-degree amounts added together is 360. And then subtracting the 50. Or you can say, well, if I know that this bit over here is 50, this has got to be 40 degrees, and then just adding 40. The two are the same. 90 minus 50 is 40. Notice that your angle in this case is not added directly as it was up here. It depends on where your vector points, where your angle is made. That's why you should always sketch it so you have a very clear idea of whether you should add or subtract. Okay? With a little bit of practice, it gets to be a lot more natural. So, in summary, there's a few things you can do to solve for finding the angle of a vector with respect to the positive x-axis. First thing, sketch it out. Very important so you can see it. Then, solve for the angle at the origin. That's this angle right here. And always put your vertical on the opposite side. Sine is always your opposite, so you should make those right there. Do not make some sort of weird triangle like this, okay? That is bad. That is bad. Make your vertical marks away from the axis. Do not put them on top of the y-axis. And then determine the measures to add or subtract as needed. That's it. With a little bit of practice, this gets to be a lot quicker and it gets to be a lot more natural. So practice that up. In fact, right now I'd say, why don't you find the angle from the x-axis, positive x-axis for, well, let's say, how about -6, 2. Give that a go, and we will talk about that more. Bring in your questions. Have a great day.